Okay, so we're going to be looking at chapter 1.5, more about data exploration. So some of the goals that we have for this lesson, we're going to become familiar with something called relative frequency circle graphs and relative frequency bar graphs. I'll explain those terms later. We're going to summarize some categorical data, and we're going to use technology to calculate relative frequencies as well. We'll do that mostly in class. We're going to practice creating frequency circle graphs and circle bar graphs, and bar graphs, sorry. So you're going to actually follow along on your note sheet that you got in class today with some of these first slides. So what is data? Again, list these on your note sheet, please. When I say data, I just mean information. So I also mean numerical. So the information can be numerical, two categories of information. The information can also be categorical. So data is just information. That information can be in numbers, or the information can just be in categories. So see if you can tell what kind of information this is. Is it numerical information, or is it categorical information? The colors of shoes worn today. So can I use a number to quantify that? If I say colors of shoes, I'm saying red, purple, green, brown, right? That's not numerical data, that's categorical. So when I'm talking about colors, that would be categorical. Socks or no socks. Again, can I quantify that? If I'm saying you're wearing socks, you're not wearing socks, again, that's going to be categorical. Next, sizes of shoes worn by 9th graders. Well, I can give that a number, right? Size 7, size 6, size 10. So that's going to be numerical data, because again, I can give it a number. Money spent on shoes. My shoes cost $40. My shoes cost $60. So again, I can give that a number. So that's going to be numerical. The heights of heels women wore on to the homecoming dance. A height, again, I can give that a number, right? 1 inch, 2 inches. So that's going to be numerical. And then I have one up here that was already uncovered. The kinds of shoes, tennis shoes, slip-ons, boots, sandals, those aren't numbers. Those, again, are categories. So the kinds of shoes right here are going to be categories. So the next question then is, what do we do with that data once we have it, that numerical or that categorical data? We can display the data and follow along in your note sheet. We can analyze the data. So we can show the data, right? We can display it. And then we can take a look at what that data means. We can analyze it. And then finally, when we display it and we take a look at it, at what it means, we can draw some conclusions from that data. So we can make some choices and decisions from that data. How do we analyze data? Let's try that again. How do we analyze data? We analyze data using measures of center. So remember what our measures of center were, right? Our measures of central tendency. We had mean, median, and mode were our measures of center, right? So that's one way that we can analyze data. Another way we can analyze data is going to be our 5-number summary. So remember, that's min, right? Minimum, Q1, median, Q3, and maximum is our 5-number summary, and we also know how to do that on our calculators. And then finally, we can use variation or deviation, other measures of spread, right? So we can look at how far values are from the mean. That's our deviation, right? How far our values are from the mean. Let's get rid of that. All right. How do we display data? There are various ways to display our data. So for numerical data, we can use a box plot. We've learned that already, right? With our 5-number summary. We can create a histogram, which we've also used. And we can do a stem and leaf plot. Now I know that one was one we were a little bit fuzzy on. We couldn't quite remember what a stem and leaf plot was. So a stem and leaf plot has, like, let's say I have 3 values, 65, 67, my board's being really picky here, and 71. So a stem and leaf plot would look something like this: 65, 67, and 71. Remember, that's our stem and leaf plot. So those are ways that we can display numerical data. How do we display categorical data then? We use this thing called a relative frequency graph, and that can come in two forms. We have a bar graph and a circle graph. Okay, so the two types of relative frequency graphs that we're going to be looking at, again, bar graphs and circle graphs. Those are for categories again. All right, so here's some examples. These are relative frequency tables. So when we put our information in a table, that's going to help us then to put it in another form, like a bar graph or a circle graph. So we look at on the far left here, we have number of cups of coffee, 0 to 3 cups of coffee, 2 people, frequency, you're going to see that word often, frequency, right? Oh, again, my board's not writing. So 2 people drink 0 to 3 cups of coffee, 3 people drink 4 to 7 cups of coffee. Again, we're looking at the far left here, 8 people, 8 to 11 cups of coffee. So that frequency in these graphs is going to be really, really important. That's going to be key. Okay, in the middle, we just have a very, very simple relative frequency table, right? Highest degree high school, 2 people. Highest degree is a bachelor's, 7 people. Highest degree MBA, 20 people, and so on. Pay attention, please, to this value down here where it says 40. Right, so if I take a look at this graph right here, down at the bottom where it says 40, that's my total frequency. In other words, that's how many people I surveyed all together, and that's going to come in really handy when we make our graphs. And then finally here on the right-hand side, this is another way it might look. People that like snowboards versus people who do not like snowboards. Well, 80 plus 25 is going to give us 105, right? Do not like snowmobiles versus do like snowmobiles, and that total is 55. If I add up those two totals, I get 160 people total. So those totals, again, are going to be really important with our frequency graphs. All right, so let's look at some key points. Relative frequency graph summarizes data. It does not list actual values. Okay, it uses percentages, but you're not going to see, if 3 people are 5 feet 2 inches tall, you're not going to see each piece of that data. You're just going to see it as a part of the whole. It compares the size of one category to all the categories. So people wearing red shoes compared to all the people wearing shoes, for example. And it's going to use fractions or percents for those categories. So we're going to see some examples here in a minute. When I say relative frequency, all I mean is that I'm comparing one specific category to all of the data points put together. So for example, if I survey everybody in the class, and there are 27 people in the class, so that's going to be our total. Let's see if I can get this to write somewhere. Here we go. So I have 27 people total in the class, and if I see how many people are wearing blue shoes, let's say it's 14. So my relative frequency is 14 compared to a total of 27. If I go ahead and grab my calculator and do 14 divided by 27, I can find that percentage, right? And that's going to be my relative frequency. All right, so to make a frequency graph, here are 4 steps. I'm going to start with a frequency table. So I want to see my data in the tables like we were showing a minute ago. Secondly, I want to find the total of all items in the category. So like in the last slide, there are 27 people in the class. That's my total for that category. Okay, so N equals, in that case, N was 27. Okay, step 2, I want to find the percentage of items in each category. So again, like we just did a second ago, I had 14 divided by 27. 14 people compared to a total of 27. If I grab my calculator and calculate that percentage, pause the video for a second, go ahead and do that and tell me what you get. So when you go ahead and divide those, you should get about 52%. It was 0.518, right? Well, if I move my decimal over twice, I'm going to get about 52%. So step 3, find your percentage. And then finally, for step 4, one other step for a circle graph, you have to use that percentage to determine the number of degrees in each piece of that circle. right? In each pi piece, what is the degree? So we're going to do that in a second, but I want you to remember that there are 360 degrees in an entire circle. So if I take that 52% and I say 52% of 360 degrees, remember of means times, right? So on my calculator, 0.52 of or times 360, I'm going to find the degree measure for that particular piece of the circle. We're going to look at that a little bit more here in a minute. Okay, there's a lot of information here, so we will practice this in class. So let's take a look at this. We're going to make a graph from some data that we have. So highest degree earned, that's the data that we have. So if you're the highest degree somebody earned in school was a high school degree, 2 people earned that degree. Okay, relative frequency, remember, is just that 2, that number of people compared to the total. So I'm going to show you the total down here at the bottom. So that's where we got the 40. We interviewed 40 total people. So I do 2 divided by 40, right here, 2 divided by 40, I'm going to get 0.05. Well, as a percentage, I move that decimal over 2 times, right? Percent means per 100. So if I multiply that by 100, I get 5%. Here's how that degrees in a circle graph come. So if I do 5% or 0.05 of or times 360 total degrees in the circle, do that on my calculator, I'm going to get 18 degrees. So when I make my circle graph, I know that that particular pi piece is going to be 18 degrees. I do that for each one of these. So for my bachelor's, I have 7 divided by 40. Total remains the same, still 40 people. I'm going to get 0.175. If I move my decimal point over twice, 17.5%. And again, over here, it would be 0.175 of or times 360. And I'm going to get 63 degrees. I'm not going to go through each one of these, but you get the idea. So 20 divided by 40 is going to be 0.5 or 50%. Well, 50% or 0.5 times 360 is going to give me 180 degrees. Right? For my next one, 0.075 of or times 360. It's always going to be part of the whole thing. The whole thing is 360 degrees. Now I have 0.1 times 360. And I have, again, 0.1 times 360. If you're not sure where I'm getting those values, we'll go over that in class. So now I have all my degree measures for each pi piece. Now if you think about what these should add up to, if I'm taking up the whole pi, that's going to be the whole entire circle. I should stop saying pi. The whole entire circle is 360 degrees. So these values should add up to 360 degrees. If you rounded, we had to round at all, we might be a little bit off in our count, but they should generally add up to 360 degrees. So what is that going to look like as a bar graph, first of all? Okay, so here's what your bar graph is going to look like. Again, here's our table on the left. Total is still 40, right? Bar graph is going to be categorical. Right, this is categorical information. So HS, or high school degree, frequency was 2. So on my bar graph, I'm not using my relative frequency. I'm not using my percentage. I'm just using the frequency. So high school degree, 2 people. Bachelor's degree, 7 people. And so on. So I'm MBA, I go up to now 20 people. So I'm just going to make my bars. It's a bar graph, not a histogram, so I have spaces between my bars because those represent different categories, not bins, but categories. So again, I'm just using my frequency and my categories for my bar graph, right? If I were getting really picky, I'd say you're going to want a title, right? Then you're also going to want to label each axis. Now I might just label this frequency, and I might label down on the bottom here highest degree. Right, so make sure your bar graph is specific. All right, let's take a look at this last one. Now I know this looks a little confusing, but let's just go with it. I'm going to move this out of the way. Oops, that's not what I wanted to do. All right, let's move that out of the way. That's the protractor that I'm going to be using. If I want to make a relative frequency circle graph, I'm going to grab my compass, or if I'm already given a circle, great. I'm going to make my circle, and I have this center. This is just the same information we had before, right? We've already done this, 18 degrees, 63 degrees, and so on down the way. So we know how big each pi piece should be. So just a reminder of how we did that, right? 2 divided by 40, and then I'm going to take 5% of 360 to get 18 degrees. Now, how do I make each of those sections in my circle graph? So I'm going to take my protractor, right? I'm going to go right in the center of my circle. So I'm going to match up my protractor with my center. I'm going to take a straight edge, so you can see my straight edge there on the left-hand side, but I'm not going to use it at the moment. I'm going to take a straight edge and I'm going to draw, oops, move that up a little bit. Take my straight edge and I'm going to draw the first part of my sector. Okay, and I'm going to lay my protractor right down on that line that I just drew, and I'm going to see where the 18 degrees is. I want to use the inside track. Those are my smaller values. So 18 degrees is going to be right about here, right? So there's my 18 degrees. So I'm going to move my protractor. I'm going to grab my straight edge. And I'm going to go up to that 18 degree mark that I made. So there's my 5%. There's my 18 degrees, or my 5% of people whose highest degree earned was a high school degree. Now when I go to do my next category, I'm going to have to take my protractor and I'm going to have to turn it so that it matches up now with the line that I just drew. Okay, so there is the line that I just drew, right? So I'm going to match it up there. And now I'm going to find my next one, 63 degrees. Turn my protractor, and now I'm going to find 63 degrees. Again, inside track, 63 is going to be right there. I'm going to take my straight edge, and I'm going to draw that mark to 63 degrees. Again, I'm going to take this, take my protractor, I'm going to turn it to match it up with the line that we just drew. So put it in the center, match it up with the line that you just drew. And my next category is 180 degrees. So this time I'm going to go all the way around. 180 is all the way down here, right? So I'm going to move my protractor again. And I'm going to go all the way down to 180. So there's that next category. I'm going to do the same thing. I'm going to turn my protractor, line it up, measure out to 27 degrees. Take my protractor, turn it, line it up. I'm going to measure out to 36 degrees. Right? And once I reach the end, what's left in my pi will be that last value. So that's kind of how I'm going to make a circle graph from a relative frequency table.